So here we have three squares sticking with each other. We try to prove alpha, beta, gamma, as in the diagram, add up to 90 degrees, right? Pi over 2. When I first got this problem, I immediately thought, okay, we can use trigonometry to prove it. I got it. However, later I realized the geometry method is much simpler. So with that as a hint, why don't you try to solve it? Yeah, using the geometric knowledge that you have. All right, so when you're ready, let's continue with the solution. First of all, with the trig, that's how would you prove it, right? First of all, you notice that alpha here is actually 45 degrees. So what we need to prove is beta plus gamma is also 45 degrees, right? So add up to 45 degrees. And here, when we look at this beta here, it is diagonal of two squares. So for sake of argument, let's assume the size of squares is 1, right? This is going to be 1, yeah? So here would be 2. So tangent beta would equal 1 over 2. Now, similarly, tangent gamma is going to be 1 over 3. Now, we want to prove beta plus gamma, so immediately you realize the trig formula you're going to use is the summation of the two angles, and the tangent would have this, trig identity. Let's do that. So let's plug it in. Beta plus gamma, right, is going to equal the sum of the two individual tangent, 1 over 2, 1 over 3, and 1 minus the product of the two, right? So here turns out to be 5 over 6, 5 over 6, that's equal to 1. So what we get is beta plus gamma equal pi over 4. We're done, right? Now let's go to the geometry method, right? So what we do here is we're going to flip the whole thing, form another, A prime, B prime, yeah, and then when we look at this new angle here, let's mark it. All right? So this angle, I claim that this is actually beta. All right, so this is beta. Why? Because when you look at the diagram, it's also formed with two squares, right? This diagonal of two squares, right? Which is the same as this beta, right? Another observation is that this is diagonal, right, of two squares, and this is also diagonal of two squares. Yeah, so which means these two sides equal to each other. Not only that, this angle is again another beta. So with that, you know that when beta and this angle here, let's say this angle 1, they add up to 90 degrees. So this whole triangle here, the big triangle here, marked in red, is going to be right triangle, is going to be isosceles. So the angle is going to be 90 degrees, 45 degrees, and 45 degrees, right? So 45 degrees here, which is beta plus gamma equal 45 degrees. All right, we're done. Straightforward, right? Let's recap. So here, we flip the figure, we construct this big triangle in red, and we make an argument that this is beta, this is also beta, and the sides equal to each other. This is the right triangle, and then we're done. Beta plus gamma equal 45 degrees. All right, thank you.